Welcome to Deep Reinforcement Learning course. This is the first discussion on the subject. So here is the complete plan document. This document is also copied to Git. The list of lectures and readings needed on the subject can also be found in the lesson plans in my Git repo. I will use PyTorch framework and OpenAI Gym in coding exercises. You have seen already a supervised learning and unsupervised learning approaches. So this course is on reinforcement learning. Mainly, there are three categories of learning. One is supervised, second is unsupervised, and the third one which we are going to discuss is the reinforcement learning. Let us see the basic difference between them. In supervised learning, we try to predict a target value or class where the input data for training is already having labels assigned to it, whereas unsupervised learning uses unlabeled data for looking at patterns to make clusters. Reinforcement learning algorithms are basically optimization procedures to find best methods to earn maximum reward. By definition, in reinforcement learning, an agent takes action in the given environment either in a continuous or discrete manner to maximize some notion of the reward. Reinforcement learning is different from both supervised and unsupervised learning. While neural networks are responsible for recent breakthroughs in problems like computer vision, machine translation, and time series prediction, they can also combine both reinforcement learning algorithms to create something better applications. The idea behind reinforcement learning is that an agent will learn from the environment by interacting with it and receiving rewards for performing actions. The learner is not told which action to take, but instead must discover which actions yield the most reward by trying them. In the most interesting and challenging cases, actions may affect not only the immediate reward but also the next situation and through that all subsequent rewards. These two characteristics, trial and error search and delayed reward, are the two most important distinguishing features of reinforcement learning. What is deep in what is deep in reinforcement learning? This is probably due to the fact that we use neural networks or deep learning to solve deep reinforcement learning problems. Where do neural networks fit in? Neural networks are agents that learns to map state action pairs to rewards. What is an agent? An agent takes actions, for example, a drone making a delivery or a Super Mario game navigating a video game. The algorithm is the agent. In life practical situations, The agent is nothing but you. What is an action? Action A is the set of all possible moves the agent can make. An action is almost self-explanatory, but it should be noted that agents choose among a list of possible actions. Environment. The world through which the agent moves is environment. The environment takes the agent's current state and action as input and returns as output the agent's reward and its next state. If you are the agent, the environment could be the laws of physics or the rules of the society that process your actions and determine the consequences of them. State. A state is a concrete and immediate situation in which the agent finds itself, that is, a specific place and moment, an instantaneous configuration that puts the agent in relation to other significant things such as tools, obstacles, enemies, or prizes. It can the current situation returned by the environment or any future situation where you ever in the wrong place at the wrong time, that is a state. Reward. A reward is the feedback by which we measure the success or failure of an agent's actions. Then there is another term, policy. The policy is the strategy that the agent employs to determine the next action based on the current state. It maps states to actions, the actions that promise the highest reward. Value. The expected long-term return with discount is called a value. The short term is basically a reward. We want to define another term called exploration, exploitation, trade-off. Before looking at the different strategies to solve deep reinforcement learning problems, we must cover one more very important topic, the exploration exploitation trade-off. Exploration is finding more information about the environment. Exploitation is exploiting known information to maximize the reward. Remember, the goal of our RL agent is to maximize the expected cumulative reward. However, we can fall into a common trap. It is only a sample video for Udacity mentorship application, not a real on the subject and or topic.